Welcome and thank you for joining us for this webinar, Introduction to Comprehensive Retrofits and Decarbonization. I'm Rohini Srivastava, Senior Researcher for the Residential Retrofits for Energy Equity at ACEEE. Before starting off with some housekeeping announcements, I'll turn it over to our interpreters to explain how you can access simultaneous Spanish interpretation during today's webinar. Over to you, Ana.
Thank you. Hi, good afternoon. Buenas tardes. Yo soy Ana Vidales y voy a estar interpretándoles este día. Si ustedes quieren escuchar esta presentación en español, tienen que irse al icono que dice interpretación, que es un globo mundial. Lo van a ver una vez yo termine de explicar. Tienen que darle clic y eligen su idioma de preferencia. También está la opción de silenciar el audio original. Si ustedes silencian el audio original, van a escuchar al intérprete a un 100%. Si no, van a escuchar al intérprete a un 80% y al ponente a un 20%. Si ustedes quieren también unirse a esta reunión por medio de su teléfono o su iPad, tienen que irse a los 3 puntitos que dicen More. Después se van a Language Interpretation. La misma opción de silenciar el audio original, eligen su idioma de preferencia. Y es bien importante, si están en teléfono o en iPad, una vez ustedes hayan elegido su idioma, apretar Done o terminar. Muchísimas gracias. Go ahead, you can enable interpretation. Thank you.
Thanks, Ana. And now some housekeeping announcements. If you could go to the next slide. So by participating in this webinar, you're agreeing to uphold a culture of respect and contribute to a productive learning environment for everyone. We are recording this webinar and will be making it available to all registrants within a few business days. To ask a question during the webinar, please submit it via the Q&A button at the bottom of your screen. You can upvote questions in the Q&A box that you would like us to prioritize. And use the chat to engage in a respectful and productive discussion with other participants. We would also like to put forward our code of conduct. R2E2 will not tolerate behaviors that cause harm or disrupt the learning environment. Please direct message Stephanie Sosa-Calder if you feel uncomfortable in this space. Disruptive participants may be removed from the webinar. All right. If we can move to the next. With that, I'd like to introduce Holly Carr from the U.S. Department of Energy's Building Technologies Office to provide an overview of the Buildings Upgrade Prize before we dive into today's topic, which is comprehensive building retrofits. Over to you, Holly.
Hi, thank you, Rohini, and hello, everybody. Just a quick overview of the Buildings Upgrade Prize, or Buildings Up. Next slide, please. So Buildings Up is a prize that is really designed to rapidly scale energy efficiency and efficient electrification building upgrades in communities across the country. The prize is envisioned to consist of 4 phases over about 5 years. Today, I'm going to be talking to you just about the first phase, phase 1, which is our concept phase, and includes over $22 million in prize money and technical assistance to winning teams. Applications for the Buildings Upgrade Prize are open now, and they will be open through July 18th. For teams to form and complete the application. We're really looking for 20 to 60 great teams to join what we're calling a co-opetition, not a competition, because we really do hope that all the teams that join us can move through the phases and succeed. I encourage you to scan that little QR code on the bottom of the slide, or go straight to herox.com/buildingsup to find all the details about the prize, rules, recordings of this webinar and others are all up there. And we do have application support available for this prize for new and under-resourced teams to get some support to apply. I'll talk a little bit about that in just a moment. Next slide, please. So stepping back, a real quick primer on why we're even focusing on efficiency and efficient electrification. The energy world is really divided into a supply side and a demand side. If you could click the slide for me. We are definitely seeing more and more clean energy entering the supply side of the market through solar and wind and so forth. We love that. That's not the focus of this prize. We're really focused on the demand side and preparing existing buildings to be able to take that clean energy and be able to use it in our buildings. And there are a couple of things that we want to focus on to prepare those buildings. One is energy efficiency. So insulation and air sealing and so forth to make sure that our buildings are using as little energy as possible. And then also efficient electric upgrades. One more click, I think. So things like heat pumps and heat pump water heaters to transition to using electricity that's coming off of that increasingly cleaner grid. So next slide, please. So our prize goals here, we're really focused on addressing those non-technical barriers to improving building efficiency and doing these building upgrades. We have the equipment, right? We have heat pumps and heat pump water heaters. We know how to do insulation and air sealing. And yet we are only seeing 1 to 2% of our nation's 125 million existing buildings receiving energy upgrades every year. So we really want to try to catalyze an acceleration in building upgrades. We want to demonstrate replicability and scalability in these initiatives that our winning teams put together. We want to be planning for the long term for holistic and long-lasting upgrade programs that can go beyond this prize. And we really want to benefit underserved communities in the process. Next slide. So along those lines, the prize has 2 possible pathways. Every team that applies will need to select one of these 2 pathways. First is our equity-centered innovation pathway. And in this pathway, teams develop innovative building upgrade initiatives focused in equity eligible buildings. So the upgrades that they do will be in what we're calling equity eligible buildings. A little bit more on that in a moment, but affordable housing, disadvantaged communities, and so forth. Teams participating and winning phase 1 in equity-centered innovation will receive $400,000 in cash prizes. And our second pathway is the open innovation pathway. So same goal of developing these innovative building upgrade programs, but there's not necessarily a focus on equity. So that teams can certainly consider equity and equity eligible buildings, but they don't need to do all or almost all of their upgrades in those buildings. Those teams win $200,000, and both pathways have access to a great spectrum of technical assistance after they're selected in phase 1. Next slide, please. This is just a little bit more detail about what the prize is considering for equity eligible buildings. So by geographic location, affordable housing, underserved commercial, and there's a team defined category. So teams can come to us and say, hey, we think these buildings should be considered equity eligible, and we'll consider those on a case-by-case basis. So a lot more information in the rules document in section 3.5. Next slide, please. So these are just some examples of the types of initiatives that teams might be putting together where they're upgrading potentially all of the affordable housing buildings throughout their community, or a school district might come as a team with a group of folks to electrify all of the schools in their building, in their district. A rural electric cooperative might partner with a community-based organization and really focus on single-family homes that are currently using propane or electric resistance heating. So those are some examples. Plus, we'd like to see innovation. Next slide, please. And use of minimum technologies. So all building initiatives should include clean heating and cooling technologies, so either heat pumps and or heat pump water heaters, plus envelope upgrades where needed to maintain energy costs. And we're seeking those innovations around addressing some of the big challenges to building upgrades, lack of contractor familiarity, high first costs, getting those pieces of equipment where they need to be installed in the right timing, having enough workforce to install all these things. There are a lot of challenges. So we're really looking for innovation in this space. Next slide, please. Want to quickly cover our application support. This is open to first-time teams who have not secured Building Technologies Office funding in the past and are representing communities with equity eligible buildings. There's a prize of $5,000 in cash and up to 10 hours of technical assistance for winning this prize. That application is open now, and the next application date is actually tomorrow, and then there'll be one more application due date on April 14th. We have a number of webinars just focused on providing information about that support prize, so check HeroX for more information. Next slide, please. And yeah, this is just the next steps. If you're interested in potentially competing in this prize, I really encourage folks to go to herox.com, click that little follow button where the red arrow is, and that will make sure that you get all the information that we put out over time on this prize. Consider applying for application support, and be sure to submit your application by July 18th at 5 p.m. And we are just thrilled to see what folks will come up with for this prize. Thanks very much. Back over to you, Rahini.
Thank you, Holly. And feel free to add your questions to the Q&A box, and we'll get to them at the end of the presentation. And I'll hand it over to Amber to walk us through our presentation today.
Thank you, Rohini. Hi, I'm Amber Wood. I am Buildings Program Director here at ACEEE. We're actually going to start with a poll. So Ethan, if you could please bring up our first poll. We would like to understand a little bit more about your organization. And so we have a few options here, and we'll give you a couple seconds to answer. And thank you for doing so. So I'm thinking that's maybe about enough time. So if you could, Ethan, if you'd bring up the results. Great. So hopefully it's popping up for everybody. We have a really nice spread here of different organizations. So thank you so much. We actually have one more question for you at the same time. So Ethan, if you could bring up the second poll, that would be great. Because we were trying to understand how familiar you are with this topic. So this one hopefully will be pretty quick, but we'll give you a couple seconds to click on that. Great. So Ethan, if you'd bring up the results. Excellent. Well, good. So thank you all so much for joining us. We just wanted to kind of level set a little bit to understand a little bit about you first, and also maybe what you know about this topic. So with that, just briefly, we wanted to go over the learning goals. For the purposes of this PowerPoint, we're really talking about building upgrades. And when we say building upgrades, we actually also mean building retrofits. A lot of resources will say retrofits, and we use the terms retrofits and upgrades interchangeably, just so you know. We are also going to talk about a little bit more about energy upgrades, specifically what they are, electrification and decarbonization, and then identify some key technologies. After that, we'll talk about strategies for designing initiatives, and then we'll wrap up with understanding the potential next steps. So Holly did a great introduction to Buildings Up. We wanted to do a little scoring overview here. So teams will submit applications composed of narratives about concept plans. And so then these concept plans will be scored based on how strongly reviewers agree with the scoring statements. And so some examples of specific areas of evaluation under these criteria are things like the team demonstrates a comprehensive understanding of the challenges to energy and efficient electrification in the building upgrade zone, or the proposed portfolio of building upgrade technologies included a minimum both weatherization and envelope improvements, as well as electric equipment installations that are feasible for that climate zone and building types. And a third example is that the team articulated a compelling vision. So just to give you some examples of the scoring as some context for then getting further into our actual agenda of talking about the upgrades and then how to do the building technologies and the terms, and we'll get through all of these. So this is our plan. So to dive into that, one of the things that we think is extremely important is centering all of this and trying to think through how both equity and affordability play into a lot of this discussion. So retrofits can bring benefits to tenants, owners, and the community at large beyond energy savings. And it's really important to both focus on people themselves, but also collaborate with the community to achieve these benefits. So we really want to start with how retrofits and upgrades impact people. Here are some examples of the types of benefits that programs can be designed to achieve. So retrofits help address frontline community priorities such as pollution reduction, gentrification concerns, and others. This webinar is going to focus on the energy efficiency benefits, and we have further a detailed webinar on financing, equity, and affordability, so that you know and can look for that one. So the potential impact from decarbonizing buildings. So in addition to the many co-benefits that we kind of just focused on briefly, upgrading buildings helps decarbonize the existing building stock. Also, we wanted to note that buildings both consist of newly constructed buildings. So we're defining those as the buildings built after 2020 here, as well as existing buildings. So the reason that we're noting this as part of the context for decarbonization is that the big bluish square underneath the new buildings are buildings built 2020 and earlier. And this presents an enormous opportunity for energy savings and emissions reductions amongst all of those buildings. So one of the questions might be, what is a building energy upgrade or retrofit, since we're using the terms interchangeably here? So before we explain decarbonization, we're going to talk a little bit about how we approach buildings. So we kind of approach them under three categories: single family, multifamily residential, and commercial buildings. The scope of retrofits and service providers who offer these services differ, as do the financing. So the idea is that the retrofit or upgrade is really intended to be a tune-up, repair, or replacement of systems or multiple systems, and that with the goal of improving comfort and reducing costs. So those are kind of single retrofits. You know, there's the possibility to simply upgrade a piece of equipment, individual piece of equipment, like a heating system. But we also want to touch here on comprehensive building energy upgrades, which are a whole building approach. So this is when we, sometimes it gets into the deeper energy savings, but really we're talking a whole building approach, which addresses multiple systems. So it's a suite of measures across a whole building, and with the idea that we're also trying to improve things like indoor air quality, moisture, as well as pest management, and make buildings more resilient. To give you just some context, typically these can achieve 10 to 20% savings, and with a really deep energy retrofit may reach deeper energy savings up to 40% for these whole house comprehensive retrofits. We also want to define a little bit what we mean by electrification. So the high upfront cost of electrification, and when we talk about that, we're meaning electrifying the building systems in a particular home. So replacing fossil fuel end uses such as heating, cooking, and even transportation with electric powered technologies. So the high costs of those are challenging for affordable housing owners, including low-income homeowners and multifamily property owners. So such stakeholders often lack the means to invest in electrification technologies and may have other priorities for any available investment dollars that we want to be sensitive and mindful of. Additional barriers to electrification may also include uncertainty and variability of monthly energy cost savings from electrification, particularly heat pumps for space heating due to differences in climate, electricity rates, fuel costs, and equipment efficiency. So we just want to note that what we're really talking about here, what we want to be talking about in the electrification space is when we talk about beneficial or strategic electrification, where we're ensuring that we're considering all of these as we're talking about electrifying building systems. Energy upgrades and electrification are often intertwined for decarbonization. So we often talk about energy efficiency as the basis for decarbonization. And that usually involves both energy efficiency from the standpoint of like weatherization upgrades, where it would be envelope upgrades, and then adding electrification of existing fossil fuel end uses like water heating and space heating. And then it can also include potentially solar and other use of carbon-free fuels beyond that as well. So with that, we have another activity. So this, I think, is actually the third question, which is, if Ethan, you could bring this up, what are your main priorities when you're thinking about developing a building upgrade initiative? So this has a little bit more reading, so I'm going to pause here and let you kind of go through the options, and we'll give you a minute and then bring up the results. So I'm hopeful that was enough time, and also that you had a little space from just me talking. So Ethan, if you could please bring up the results. Yeah, so your main priorities, the highest one is return on investment, followed by a tie between biggest greenhouse gas savings and upfront costs for a building owner, which are both very important considerations. So thank you for answering that. All right, so next we get into our key technologies, which I will get to our next slide here. And Rohini is actually going to take this next section. So over to you, Rohini. Thank you.
Yeah, thanks, Amber, for setting the stage and getting all the terms up front. One of the main things, if you could advance to the next slide, is to really select the right suite of technologies to achieve energy savings and improve comfort in a building. And in the next few slides, we'll walk you through some candidate technologies that offer opportunities for comprehensive savings. And these range from envelope upgrades, heat pumps for heating and cooling, lighting appliance, plug loads, alternative measures, and distributed energy resources and EV integration. And we'll get into details for some of them in the next few slides. And just as a side note, for the buildings up price, the minimum technologies are clean heating and cooling technology that includes heat pumps and heat pump water heaters, and envelope improvements where needed to reduce energy costs and improve comfort. Next slide, please. So the first technology we're talking about are envelope upgrades. And envelope is actually the barrier, is the separation of the interior and exterior of the building. So the envelope is that separation, and any measure that helps to make that separation more efficient is what we'll be discussing in the next few slides. A well-insulated and well-sealed building envelope is critical to ensure the installed technologies perform as expected. Leaky buildings will force the equipment and the appliance to work harder to deliver comfort, particularly when we are talking about space heating and cooling, and may even negate the benefits of upgrading to an efficient electric technology. So when we talk about measures, these could include air sealing, duct sealing, And there are new technologies such as sprayable sealants, membranes. It includes insulating windows, wall, attics, and foundation, door and window replacement. And part of it is also installing secondary windows. These measures can typically save 15% of heating and cooling costs in a home, or overall 11% of the energy costs. And in a retrofit, when the building, reducing the building energy demand as much as possible should be a key priority. And that should precede equipment replacement. Efficient building envelopes reduce the needed capacity of an HVAC equipment and possibly the associated electrical capacity. And this can help us reduce upfront costs for that equipment and lower the energy costs. And the same principle can apply to other end users. And these measures are very critical in the heating dominant cold, mixed humid, and marine climates. And older homes in these regions can really benefit from such upgrades. Next slide, please. So the next technology is secondary windows. And these windows are inserts, especially in windows that are single pane. And we have seen that single pane windows are the weakest energy efficiency link in a building envelope. Windows account for approximately 39% of the annual US energy used to heat commercial buildings and 28% of energy used to cool the buildings. So secondary buildings are higher. These higher performing windows can reduce the annual US energy use by up to 75%. But replacing windows can be really expensive. So these new kind of building inserts, window inserts, provide the same performance as a typical window for about 10 to 25% of the cost. These are lightweight, high performance, ultra thin glass that's insulated in a low fiberglass frame. So on the right, you'll see it's an insert that's put into an existing window frame. It reduces air infiltration, can result in additional energy savings, and accelerate the payback, particularly in cold climates. And it can also reduce the operating expenses through lower heating and cooling fan loads. And they're easy to install and do not require holes to be drilled in the existing system or require any permanent attachment devices. And they have additional benefits of reducing exterior noise, window condensation, and air leakage. Next slide, please. So the next technology we're talking about are heat pumps for heating and cooling. Heat pumps have emerged as an important technology as they perform both space and water heating. And they can be a vital strategy to decarbonize buildings, especially in the affordable housing sector, as they offer high efficiency, ability to provide cooling in addition to heating, and increasing the capability to function in cold climates. These systems are about 3 to 5% more efficient than standard electric or gas heating systems and come in many varieties. Ducted heat pumps are split systems that rely on a ductwork, and therefore they can be used in existing central distributed system. In an apartment that does not have an existing ductwork, ductless mini splits may be a suitable option, as they are smaller in-unit systems that provide enough heating and cooling for a specific zone of the house. And new market viable package units are also being tested. An example is the New York City Housing Authority and New York Power Authority and the New York State Energy Research and Development Authority, NYSERDA's program that brings to market simple cold climate heat pump replacements for room air conditioners, commonly found in many multifamily properties. 2 manufacturers have been selected to develop these heat pump models that reduce energy use and carbon emissions to meet the state and city's climate targets and provide opportunity to procure low-cost accessible window units. Next slide, please. The next technology is heat pump water heaters. So instead of heating indoor spaces, this equipment using electricity, refrigerant, and coils heats the water. And they can be 2 to 3 times more efficient than conventional electric resistant water heaters. These systems there are different products available. There can be an in-unit water heater, a shared heat pump water heater with high capacity and high efficiency that is shared between 2 to 3 apartments, or a central system in a mechanical system, in a mechanical room. And there are also retrofit ready plug and play 120 volt heat pump water heater technology available, which does not require expensive panel upgrades and rewiring. And there are some unique considerations, including location and space consideration, as well as attention to noise from these systems that customers and initiative designers need to be aware of. Next slide, please. So the next set of technologies are lighting, appliance, and plug loads. Most of us know about LED lights, and here we are encouraging people to upgrade 100% to LED lights, use sensors and controls. Next set of upgrades are upgrading home appliances, then installing smart electric panels and smart splitters. A smart panel is really a smart technology-enabled electrical panel, which monitors energy use in home and helps the homeowner control those loads. And then the last one is just making sure we're upgrading to Energy Star certified consumer electronics. Next slide, please. There are also some alternative measures to heating and cooling systems in buildings. And these are simple systems or equipment that are available at a lower cost. And these include window attachments such as low-E storm windows, cellular shades, and solar screens. So on the right, you'll see a couple of examples that show you what these window attachments could look like. And the Attachments Energy Rating Council provides a rating, certification, and labeling of window attachment products with energy performance scores to help consumers compare these products. You could include ceiling fans and also look at thermostatic shut-off valves and tub spout diverters as other alternative measures. Next slide, please. So while we discuss some of these key technologies, there are some strategies that can help people plan initiatives. And in the next few slides, we'll quickly get into some of the top strategies we think would be useful. Next slide, please. So this is just a summary in terms of what those strategies could be, and we'll jump into some of those in the next slide and the following ones. So the first one is understanding community priorities, collaborating with stakeholders, designing packages, and coupling them with electrification, and also thinking through financing and other incentives. So next slide, please. So the first key strategy is to understand community priorities and engaging and collaborating with community around what are their needs. Are there different segments of a community that have different priorities, and how can an initiative tailor their offerings to meet those needs? Next slide, please. And that includes collaborating with a bunch of stakeholders, and we list some of them in this. And they include building owners, managers, government agencies, developers, financiers, utilities. And while we are collaborating with stakeholders, it's absolutely important to plan a team that represents all these stakeholders and includes residents, building occupants, in creating and implementing the initiative. Next slide, please. So standardizing retrofit packages is really about developing a set of standard measure packages that are designed to address common needs and opportunities in a building type. And these packages can meet carbon reduction goals, reduce energy costs, and increase comfort. And the packages are still customized for homes. That are the specs are the specifications for equipment and technologies will be determined based on the existing conditions, but there's definitely a set of measures that one can choose from. And on the right, we show examples of what a package could look like. For a commercial building, it may include lighting and occupancy sensors or automated shading response. In a home, it may include a package with attic insulation and an equipment upgrade. And this kind of a process this strategy can enable more contractors and customers to undertake a retrofit project by reducing overall project costs, the acquisition times, and customer inconvenience that is associated with a highly customized approach. Next slide, please. While we touch this in the key technologies, the next strategy talks about incorporating low-cost measures in an initiative. This reduces energy use, utility bills, and emissions while improving comfort. And it includes alternatives to traditional measures addressing heating, cooling, water heating, and lighting. It could include weather stripping, pipe wraps, storm windows, spout diverters as some example. And it may also include supplemental measures that save energy and other end-use categories. And these could be in a unit. So if you're talking about a multifamily upgrade, these low-cost measures could be included in one single home or unit. Next slide, please. The next strategy is about staging retrofits to meet customers where they are. And splitting into stages can make the process less complicated for customers. It could include pre-retrofit measures such as health and safety measures that are such as deferred maintenance and mold remediation actions, and then get into more of the complicated equipment or envelope upgrades. All things being equal, envelope upgrades should be considered first as they make the buildings more efficient, and then get into equipment and system upgrades. This approach helps optimize the system and avoids oversizing. However, there might be instances where a system is nearing end of life. And in those situations, equipment replacement becomes a priority, and other measures can complement that upgrade. Splitting also allows customer to take immediate actions first, and it also enables an ongoing engagement to support completion of a full retrofit over time. Next slide, please. The next strategy is coupling electrification with retrofit projects. And this helps maximize emission reductions and improves overall performance. It also reduces the cost of electrification where natural gas is cheaper. And at the project level, electrification can increase cost effectiveness and facilitate the transition to a decarbonized building stock. And when electrification, or such as upgrading the heating or cooling system, is done with an energy efficiency upgrade, such as weatherization, it does not require many additional steps, such as a panel upgrade or additional appliances to monitor. And it also influences the equipment choices to quite an extent. Next slide. So the final strategy that we get into detail is offering financing and other incentives. Customers often have limited access to capital to invest in efficiency and/or electrification measures. Affordable financing approaches and incentives can help reduce that cost barrier. And on right, we show an example of how MassSave is offering heat loan program at a very low interest rate to customers who want to switch to electrification measures. Although we are touching very briefly on this strategy, but please do join us for an in-depth webinar on this very topic of accessing funding sources. And we have more of that information later on in the presentation. Next slide, please. And just to wrap up, there are the tech strategies we discuss are not truly exhaustive. There are others that can help make the process much easier and get more buy-in, such as establishing a single point of contact, marketing multiple benefits of efficiency and decarbonization, and expanding the direct install measure offerings. And I'll leave that with you and hand it back to Amber to take us home.
Thank you, Rohini. So just a few more slides. So potential next steps for planning an initiative. We have a number of next steps listed here. Of these, securing adequate funding and financing is perhaps the biggest hurdle, but Rohini had already mentioned that we'll have a webinar focused on that. And that affordable housing providers generally cannot do substantial upgrades without financial aid and technical assistance. We do want to note how big of a hurdle that potentially is. Phase 1 winning teams and buildings up will receive technical assistance to support many of these next steps. And we suggest forming a team and submitting a phase 1 application by July 18th to be eligible to leverage additional support. So hopefully these were the learning goals and you have takeaways in each of these topics. So talking about building upgrades and retrofits, that you kind of understand the energy upgrades and then electrification and decarbonization, some of the technologies and strategies for designing initiatives, as well as the next steps. We do have a number of resources and this will be available so you can look into some of these details more. And then as mentioned, we do have a number of upcoming training webinars on different topics. So please join us for additional detail and nuance into each of these topics. And with that, I just wanted to say thank you, and hopefully we can open it up for questions.
Before we get into questions, I think we have one last poll that we wanted to run. Ethan, if you could pull up the last one on what key areas people would like to learn more about and give a minute or two.
And note that there's 2 questions here, so please, if you could answer both of them, that would be lovely. And thank you, Rohini, for reminding me about the poll. So I'm hoping that's about enough time because we do want to have time for questions. So Ethan, could you bring up the results? Oh, very interesting. Okay, so the key one of the most questions is are strategies for designing initiatives. And then exploring more at group technical assistance or case studies and program examples. So thank you for that. All right, Rohini, are we on to questions now?
And I'll invite Ian to ask questions to the panel.
Hey everyone, I'm Ian with the R2E2 team at ACEEE. So we'll start off with a question specifically about the Buildings Up prize. So I'll give this one to Holly. The question is, do projects have to include electrification? What about natural gas heated homes doing weatherization and upgrading to high efficiency equipment?
Yeah, thanks, Ian. The prize is focused on energy efficiency paired with efficient electrification upgrades. So more efficient fossil fuel equipment is not eligible for this prize.
Great. And then we have another question. It's related to the application deadline. How quickly after the application deadline will the prize be awarded and the funds be distributed?
So we are trying to do this as quickly as possible. For the application support prize, which is open right now, and we are actively making awards for that, we are trying to be able to distribute prize funding within 15 days after we receive paperwork from the winning teams. And for the larger prize, for the phase one, $200,000 and $400,000, the same would be true, that we would be looking to announce winners, request paperwork back from teams, and once we have that paperwork, make those awards within 15 days. I see Sarah coming on as well. Do you have anything to add, Sarah? Okay.
We have one more question related to the prize. Can applicants apply to multiple DOE grant programs? Is the limitation just for the application support?
Okay, I think I understand the question. So for the application support prize, which is that $5,000 and 10 hours of technical assistance, we do have a requirement that the lead applicant for the application support has not received Building Technologies Office funding in the past 5 years. So we want to see that you're new and you haven't successfully done that in the past. That is just for application support. That is not a requirement for the main prize for the phase one, 200,000 or 400,000. If you have received funding from DOE or from Building Technologies Office in the past, that's okay for the larger prize. I hope that is responsive to the question.
And we actually have one more question coming in related to the prize. The way I understand this is, can projects do a dual fuel cold climate retrofit?
So yes, dual fuel or a gas backup is allowed if necessary for the heat pump upgrade. So in some places that's necessary, as long as that efficient electric equipment is going into the home, and that's the building, and that's the primary use.
Great. So we'll move on to the broader questions, not specifically related just to the prize. The first question is for Rohini, and it is, what sources are used to determine percentage of energy savings? Are these pretty standard? Is there a reference site for these averages?
So if I'm understanding the question, is it about determining the energy savings from the building? If that's the case, there are multiple tools that you can use to model your energy and your building stock, building characteristics to get the energy savings. And you can get into as much detail as you want, but there are also some decision support tools, such as PNNL has a retrofit decision tool where you can quickly input some of the building characteristics to get an output and a direction on which technologies make sense. Let me know if that was the question around getting those energy savings and emission savings. I'm happy to follow up.
And it looks like there's a related question that you may have just partially answered. It's just, what resource do you suggest to determine emission savings calculations?
Yeah, I think one of the key ideas of designing any kind of a retrofit initiative is to be paying full attention to what climate or building stock are you trying to retrofit or upgrade. So those things would definitely change. And there are multiple modeling tools out there where you can change those parameters to get response or a result that's much more in line or much more relevant to that building region and climate zone.
And then we have a few questions which I'll give to Amber. Oh, hold on one second, sorry. And the first question is there a reliable source of data demonstrating the customer cost of energy before and after electrification or efficiency upgrades, separate from capital costs and associated tax credits and rebates?
Yeah, that's a really good question. There are a few reliable sources and a number of research reports that are kind of coming out right now. So we have listed some of those in our resources slide, so I would recommend looking at that. There's not one single place, though. Let me just say that there are a lot of places, though, looking at operational costs and trying to disaggregate those, obviously, from the upfront costs, but it does depend. And it can be quite a detailed and nuanced discussion, depending on if you're also really looking at the carbon savings as well. So I know that's not a full answer, but we do have some in our resources. And again, happy to follow up if you want to get into that conversation further, because it can be a pretty complicated answer. So hopefully that helps.
And then we have another question that is, has anyone considered the waste that will accumulate from the changes we will make when going from gas systems to electric?
So I'm not sure exactly, so one of the things that I think we should be very clear about is that both for affordability considerations, as well as when you're thinking about materials, when we're talking about replacing HVAC and heating equipment, we're talking about replacing those near or at the end of life, right? So there definitely are different entities looking at embodied carbon, for example, if we're talking about waste from that aspect, and looking at kind of life cycle type cost analysis of replacement of equipment when you're fuel switching, and a number of those types of detailed analyses, some of which we're looking at, some of which others are looking at as well. So yes, that is being considered when we start to think through kind of life cycle type analysis, either from an energy perspective or from a carbon perspective, both of which are being considered. I actually also know Rohini knows a lot about life cycle, so I don't know if you have anything else you want to add to that, but happy to give space if you had anything else that I might have missed. Yeah.
No, I think you pretty much captured that. But one thing to do to take notice is, as we mentioned, most of these swap or replacements are happening at the end of the product cycle anyway. So those considerations need to be taken into account, and life cycle assessments and life cycle analysis pretty much takes that from the cradle to grave and cradle to cradle perspective. So if you're looking at equipment, there's definitely detailed studies out there.
Great. So that is all the questions that we received. We do have a few more minutes, so I'd invite participants to add additional questions if you have any.
I could offer a slight elaboration on the answer about prize payments. I read the question more closely and it says, how quickly after the application deadline will the prize payments be awarded? So application deadline for phase 1 is July 18th. And then we'll have a review and selection process. And so announcements are expected about 2 months later. So the prize payment after announcement is generally, the process is the winners send NREL some paperwork and then we can cut a check within about 15 days. But the application deadline to the prize payment really depends on that review and selection and announcement time frame. So for this prize, we're expecting application deadline in July, announcements in September, prize payments likely in October.
And then we have another question that came in specific to the prize funds. It is, can the funds also be applied to panel upgrades if needed?
I can take that one, Ian. And yes, prize funds can be applied. Once they are awarded to the team can determine how they will use those funds. That said, $200,000 and $400,000 is not a lot of equipment, right? So the idea is really that teams are developing initiatives that will upgrade many, many buildings, and it's a capacity building prize to help support staff and program development, and that teams will be looking at holistic ways to stack funding, rebates, incentives, financing, and so forth to pay for those individual upgrades. Not so much that the prize funding would actually pay for equipment, although you could potentially buy a little bit of equipment with those funds. I hope that's clarifying.
And I think the only other, the last question that came in is just, again, related to a resource for determining emissions savings calculations, whether that resource is available in the resource list that we'll be sending out with the presentation.
I can try to answer that. So guessing from the question, it's more around what resources and tools are out there to help determine the savings calculation. There are some tools and we can definitely follow up with those. There's simple back of the envelope kind of analysis, as well as more sophisticated modeling tools like Energy Plus that you can get into, but we're not recommending any of those, either one of those, or you can share a list of resources that one you could look into.
And if we have time, there's one more question coming in. Maybe we can address it just really quickly before we end. It's related to the minimum or maximum number of buildings that needs to have upgrades planned. Is it a good idea to start with a few single family houses? I'm not sure if I'm getting to the meat of the question.
I think I can take a stab at this.
Sure.
The person is asking about the maximum number of buildings needed for an upgrade initiative. And though we do not specify a minimum number or a maximum number of buildings to be upgraded, I should be clear that the Buildings Upgrade Prize is for development of building upgrade initiatives that will address many, many buildings. So this is not a prize to do a pilot project where you do a efficiency and electrification upgrade in one building and it's a pilot. This is developing building upgrade initiatives that address many buildings. We do not specify how many buildings, but suffice it to say applications that include many, many buildings will be stronger than those that do not.
Great. So I think we'll have to leave it there. Thanks everyone for your questions.